In this video, we'll calculate the standard error value of the y-intercept, standard error value of the slope, R-square or the coefficient of determination, F statistics, and the regression sum of squares. We will use this formula or functions to do the calculations to verify. Begin with the 1 data x matrix. And equals array formula of the x values. We calculate the pseudo inverse. And multi transpose of this matrix and itself. And we calculate the cofactor of the pseudo inverse and multi transpose of this matrix, one matrix, and the y values. Now that we have the pseudo inverse and the cofactor, we can multiply them to calculate for the coefficients. Of course, this verifies our coefficients. We have this slope 1 and the intercept. Next, we calculate for the standard error value of the y-intercept, which is equal to stay x times the square root of J2, and this matches to our LINEST output, and this is stay x times the square root of K3, which matches to our LINEST output. Then the coefficient of determination we calculate using ESS over TSS, but before we do that, we have to calculate for the TSS. TSS is n times variance of population y, so n equals the rows of the dataset, and variance of population y equals variance of population y. So the total sum of square equals the variance, the population times the variance of the population y. Now that we have the TSS, we also calculate the degrees of freedom of the numerator, which is equal to columns x. And since we only have one independent variable, so that's the value of 1. So we can calculate the regression sum of squares equals TSS minus RSS, or the regression sum of squares. And this matches to our LINEST output. The degree of the F statistic is equal to ESS divided by degree of freedom of the numerator all over RSS divided by degree of freedom of the denominator, which is 151.678, matches to our LINEST output. Next, we calculate the coefficient of determination, which is RSQ or R squared equals ESS divided by TSS, total sum of squares. So we have 0.95588, matches our calculations. Next, we calculate the Pearson function of this data set. You also get the same result using correlation. of the data set. And you also get the same result using the covariance formula, which is covariance divided by the geometric mean of variance of population X and the variance of population Y. You can also, all this, if you square this value, you get the value of R squared, or the coefficient of determination. R squared has its own function, RSQ, data Y, and data X.